So in order for us to solve the next set of trig functions, we're going to need factoring. So before we factor each trig function, we'll just do a regular factoring so that we can recall all those beautiful algebra skills that we had. So the first one wants us to factor x squared minus x minus 2 in order to solve the problem. So remember, when we're factoring, we're asking ourselves, what are factors of negative 2? Yep, factors. Factors of negative 2 that add to negative 1. Negative 2 and positive 1, right? So we would say x minus 2 and x plus 1 equals 0. And then from there, we take each set of parentheses and we do x minus 2 equals 0 and x plus 1 equals 0. And then we solve those bad boys, right? Hopefully we can solve those in our head by just adding 2 to both sides and getting x equals 2. Subtract 1, x equals negative 1. So we have 2 answers. It's all coming back. So same exact thing is going to happen with b. The only difference is, instead of just having a plain old x, now we've got that sine function connected to our x. So we're still going to ask ourselves the same question. We're still going to say, okay, what are factors of negative 2 that add to negative 1? Because I still have a constant of negative 2, so I still want factors of negative 2 that add to negative 1, because my coefficient here is really negative 1. And I basically just pretend that the sine function isn't there while I'm factoring it, while I'm finding my factors. And then when I write my set of parentheses, instead of just having an x, I'm going to have a sine of x, because that's my entire variable basically that I'm working with. So I still want to know what multiplies to negative 2 and adds to negative 1, which we already said was negative 2 and positive 1. So then my parentheses are just going to be sine of x minus 2 and sine of x plus 1 equals 0. And then just like before, I'm going to take each set of parentheses, set them equal to 0. So I have sine of x minus 2 equals 0 and sine of x plus 1 equals 0. And then I want to get the sine functions all by themselves, right? So then I get sine of x equals 2. And here I get sine of x equals negative 1. And then I'm going to quickly erase this so I can drop in the unit circle over here so we can use the unit circle. To answer our question. So now we want to know, where does sine equal 2 and where does sine equal negative 1? We know sine is our y value, right? So the first thing we're going to do is look for y values that are just 2. As I go around the circle, I see a 0, 1/2, root 2 over 2, root 3 over 2, a 1. Then my numbers start to get smaller again, right? Back to 0. Then they're negative, so they're even smaller. Do I ever actually have a y value of 2? No. It's outside of my range. I'm never going to have a y value bigger than 1 or smaller than negative 1. So when they're too big like that, like you get a 2, if you got 1.5, you get 5, those things are no solution. There's not an option there. So the first part is going to give us no solution. But we can still get an answer from sine of x equals negative 1. So now where sine of x equals negative 1, we want to know, where's our y value -1. So I'm just going to look around my circle, and I see my y value is -1 down at the bottom, which is my radian value for 3 pi over 2. So the only answer I'm getting here is that x can equal 3 pi over 2. So most of the steps are exactly the same. We're just adding in the one more step where we've got to factor it first and then take our factors and set them equal to 0. And then once we take our factors and set them equal to 0, we're just solving in the same exact way we've been solving. But we also know from Algebra 2 that there are all sorts of ways we can factor, right? So we can also factor the greatest common factor, right, which is when they share something. So these are our problems that share something. And if we look at the first one, we've got x to the 4th minus 4x squared equals 0. So we see that both terms have x's in them, right? They share x's. They actually both share an x squared, right? So I can take out an x squared. When I do that, then I want to know what's left over after I factor out the x squared. Yes. And I get x squared minus 4 because I go in and I divide each term by x squared. And when I'm dividing things with exponents, I subtract their exponents. So once I do that, I get 0. Then I take each factor and set them equal to 0. Then I'm going to square root it. So I get x equals 0 because square root of 0 is just 0. The other one I'm going to add 4 to both sides and then square root it. So I get x squared equals plus or minus 2. Ooh, not x squared, just x. X equals positive or negative 2, or x equals 0 would be my answers there. So same thing again when we're dealing with b, where it's cosecant all to the 4th power minus 4 cosecant squared equals 0. So we're asking ourselves, what do they share? So in order for us to even use the GCF, the first thing we got to make sure is that we're working with the same trig functions, right? Because if the trig functions, if I had sine and a cosine, then they don't match, they don't share anything. They've got to have the same trig functions in order for those variables to be similar. So I see they both have cosecants. They actually both have 2 cosecants that they're sharing. So I can factor out a cosecant squared x. When I do that, it follows exactly the same rules. I'm still dividing everything by a cosecant squared x, so I'm subtracting their exponents, which means I'm left with a cosecant squared x minus 4 equals 0. And then I take each one and set them equal to 0. And I'm going to solve it, so I'm going to take the square root over here. I'm going to get cosecant of x equals 0. Personally, I would not like to work with cosecant on the unit circle. I'd rather change it to its reciprocal function, which is sine. Sine of x, which means I need to find the reciprocal of 1 over 0. So I'm looking for where sine of x is 1 over 0. Is 1 over 0 an actual number? No, it's not. It's undefined, right? Are there any places on our unit circle where our sine value is undefined? No. So we're not going to get a solution here. We do have to be careful, though. You can't always just assume because it's undefined that it's no solution, because there are places where the tangent and the cotangent would end up being undefined. Because remember, tangent is your y value over your x value. So if your x value is 0, you could end up with an undefined tangent. So it's not necessarily always going to be undefined. Just gives you no solution, but in this situation, because they're asking if the sine value is undefined, this one is no solution. Then we're going to go over to the other one. I'm going to add 4 to both sides. I'm going to get cosecant squared x equals 4. And then I'm going to square root both sides and get cosecant x equals positive or negative 2. So now again, I want to flip it to be my reciprocal, right? So I want to know sine of x equals positive or negative 1/2, because the reciprocal of 2 is 1/2. So I want to know where are my y values, positive or negative 1/2. So I'm going to grab my unit circle again so we can look at it. My y values are positive or negative 1/2 any time I'm dealing with a denominator of 6. So all of my answers here are going to be x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So it's still exactly the same steps. Once we break it into two equations, once we separate our factors, you're just finishing it the same way we were solving before. It's just the added step that we've got to factor it first before we finish solving it. I want to show you one more that needs the bottoms up method. Factoring when you have an actual number in front of your x squared. It's not just x squared. So if I had given you a, 2x squared plus 3 equals 7x, and I asked you to solve 2x squared plus 3 equals 7x. What's the first thing you have to do there? Yeah, we got to bring the 7x over so that the whole thing is equal to 0. So I really want it to be 2x squared minus 7x plus 3 equals 0. And I subtracted 7x since it was positive to begin with, right? So I want to do the opposite. Then I want to ask myself, okay, what's 2 times 3? 6. So I really want factors of 6 that add to negative 7. So anytime you have a coefficient in front of that x squared, we've got to multiply those, the constant and the coefficient together, and then find factors of those two. Negative 6 and negative 1. Perfect. So then I'm going to do the same thing, and I'm going to say, okay, x minus 6, x minus 1 equals 0. But because I multiplied by 2 in order to get those factors, I didn't just take that 3 out, right? I multiplied by 2 to begin with. In order to undo that multiplication, I've also got to divide my factors by 2. So then I'm just going to simplify as much as I can. So I really have x minus 3. And here you have two options. If we were just factoring back when you were in algebra, they would have taught you to take this and bring it up to the front and make it 2x minus 1 so it was prettier and you had all whole numbers. You're more than welcome to do that, but since we're solving, it just makes you solving 2 steps instead of 1. If we just leave it as x minus 1/2, then you just have to add 1/2 to the other side and you're done. So totally your choice. If you want to go with get rid of all the fractions and then solve, you absolutely can. If I were you, I would just stay here, because even though x minus 1/2 isn't as pretty as 2x minus 1, when we go to solve it, now we just have to add 1/2 to both sides, and 0 plus 1/2, we can handle that, right? Instead of having to add 1 and then divide by 2. So I would leave the fraction if I were you, but personal choice. Then I set both of my factors equal to 0. And I add them to the other side. And end up with x equals 3 and x equals 1/2. So you just got to remember when you have that coefficient out in front, you got to multiply the factors together and then divide the factors by whatever that coefficient is. Just an added step in there when we're factoring. So same thing with our example B. 2 sine squared x plus 3 equals 7 sine of x. I still have to move that 7 sine of x over first. So I get 2 sine squared x minus 7 sine of x plus 3 equals 0. So I still want to say, okay, what are factors of 2 times 3? They give me 6, so I want things that multiply to 6 and add to negative 7. We already know that it's going to be negative 6 and negative 1. So I'm going to have sine x minus 6 sine of x minus 1 equals 0. And then I have to divide both of those factors by 2 again because I multiplied by 2 to begin with. So I divide by 2 here, divide by 2 here. So I really have sine of x minus 3 sine of x minus 1/2 equals 0. Take both of my factors and set them equal to 0. And then I need to solve both of them. So I'm going to add 3. Am I ever going to have a place where sine of x equals 3? No, it's too big. The number's too big. No solution. Here I have sine of x equals 1/2. So I want all of the y values on my unit circle that have a value of 1/2. So it's going to be only in the first 2 quadrants because y is only positive in the top half of the unit circle. And then I know my y values are 1/2 at pi over 6. So that means I'm going to have pi over 6 and 5 pi over 6 as my answers. What do we think? Not as scary as it was the first time we started doing these? We're getting better? All right, let's look at your classwork together so we can sort out any issues on the classwork.